Before we quit, let's add one last level of complexity to our problem. Let's say that we're going to not rotate around the x-axis down here. We're going to come up to an axis that's parallel. And we could pick it anywhere, but I'm going to just pick it for fun because it fits on my drawing. At y is equal to 2. This axis right here. And we're going to rotate to create a volume by rotating. Okay? So we're going to get another kind of cup, but it's rotated around this axis, not this axis down here. So, because we're still parallel to the x-axis, the washers that we're creating here are going to have a thickness in the dx direction. So we know that that's going to still be dx. And we're going to have pi. And now we're going to have our outer radius squared minus our inner radius squared. Okay? But the trick is figuring out what these outer and inner radii are. Okay, so we're going to come up here and pick a point, it doesn't matter where, on our center of revolution. And we're going to draw a line down until we get to the outside of the vessel, the volume. We come down here like this and we hit, okay, there it is. Okay, we're on the 1/2 x here. But if we just plugged in x at this level, we would get this little bit right here. But that's not what we want. We want this bit. How are we going to get that? In other words, we want this section, not this bit. Well, you see, everything starts up here at 2. If we subtract out this part, we get what's left over, which is actually our outer radius. Okay? And that's just exactly what we want. So we're going to plug in 2 minus, now our equation is 1/2 x, so we put 1/2 x squared. Okay, that's taken care of. Minus, now we need to figure out our inner radius, so we start here at another point, just to make it clear on our drawing. We come down here and we hit this. We're hitting this function, but once again, we don't want the value, the square root of x. We want 2 minus the square root of x to give us this portion. We subtract out this portion, so we get 2 minus the square root of x squared dx. Integrate that from 0 to 4, whatever you want, a to b times pi, and there we go. I'll leave you to plug in those numbers if you'd like, but that's how we move the axis above. Moving it below, I think, was more intuitive. This is a little more complex, exactly what takes place. But if you draw it carefully, you think about your outside radius, your inside radius, how it all fits together, hopefully you can get it to work.